So far this unit we talked about quadrilaterals, right? Now, some quadrilaterals are classified based on whether or not opposite sides are parallel or not, right? Or if adjacent sides, meaning the ones next to each other, are perpendicular, right? So what's a quadrilateral where opposite sides might be parallel, and that's how we can classify it? Parallelogram, right? What's a polygon where opposite sides might be perpendicular? Notice I said polygon, so we can include triangles. What's one where opposite sides might be perpendicular? Not opposite, sorry. Adjacent sides perpendicular. Next to. We have a right angle. What's a polygon with a right angle? Square. A square. What else? Right triangle. Right triangle. Rectangle, right? So those are all ones where we have right angles. Now to determine right angles or parallel lines, we use what formula? Nope. So we did on Thursday. Nope, begins with an S.
Wait, S.
Nope.
What was it again?
Just the term begins with an S. We just talked about it.
Slope.
Slope. Good. Okay. If two lines have the same slope, then they are parallel, right? Right?
Yep.
If two lines have negative reciprocal slopes, then they are perpendicular. Right? So parallel lines, perpendicular lines, that's one way we can classify a quadrilateral. Okay? Another way we can classify a quadrilateral is by the side lengths. What are some quadrilaterals that depend on side lengths? Square. What do you want square side lengths? Equal. They're all equal, right? Anything else? Equilateral triangle, right? What do you know about those lengths? They're all equal, right? What about a scalene triangle?
Two of them are equal.
They're all different, right? No lengths are the same. You're thinking of isosceles, Kevin. Okay. What about kites? Adjacent sides are equal, right? So the two on the top are the same, the two on the bottom are the same, but they might be all different lengths, right? So being able to figure out the length or the distance between 2 points, you think that's going to be a valuable tool or unvaluable? Think it'll be useful or not useful? Useful. Okay. So if I have these 2 points A and B, let's say A and B are the sides of some polygon. A and B are the vertices. They make up the side of any polygon. You could pick your favorite polygon. I don't care which kind of polygon it is, but A and B are the side of it. Does that make sense? Okay. Now I want to know how long that side is. Okay. It's hypotenuse of what? Okay. You're on the right track there. Was that a guess, or is this something you've done before? Something you've done before. Okay. Now, when we looked at the slope, we would find the rise and the run, wouldn't we? Right? What's the rise? I want to go from A to B. What's my rise? We go down, right?
That's not rising.
Okay. It's negative rising, right? Right? So this right here, guys, this is my rise or my change in Y, isn't it? Right?
C.
Where's my run?
To the right.
To the right.
Watch out.
Now, it doesn't matter which one I do first, but either way, if I go down and then over from A, okay, or I go up from B then over, I'm going to travel the same distance. I'm going to travel this change in Y, that change in X, right? Right? Now, what do I know about the change in X and the change in Y line? What do I know about the angle made by the green line and the blue line?
Right.
What is it?
Right.
It's a right angle, right? Meaning it is 90 degrees, right? What theorem? Pythagorean Theorem. What does that tell us?
A squared plus B squared equals C squared.
Good. A squared plus B squared equals C squared. Now, which one's C? Green, blue, or black? The black line, hypotenuse, right? Now, we're talking about distance between A and B, so we're going to call this one D. Okay, does that make sense?
Sure.
So in this formula, which one does D go in for?
C.
C. Now, is it okay if I rewrite this formula this way? C squared equals A squared plus B squared? Is that okay? Okay. So D, you said, goes in for C, right? So my distance formula, it's like I have this. D squared equals what? What's my A?
Y.
Y, okay. Not just Y, but the Change in y, right? Delta y means change in y, right? And then what's my b?
Triangle X.
Okay, change in x, delta x.
Where do we get delta from?
Delta, it means change. It's a Greek letter. Okay, delta is a Greek letter. In math, we denote it as the change in a variable. Okay. Now, change has a certain mathematical operation tied to it. Do we know the operation?
What?
What is it? Subtraction. Good. Change is subtraction. It's like that whole lunch example, right?
Yeah.
I had $10 before lunch. I have $8 now. What's my change?
2.
2. How much did my lunch cost? $2, right? It's a subtraction problem. My change in y is a subtraction between my first y value and my second. Change in x is a subtraction between my first x value and my second, right? So now these points A and B, we could call these, they have x comma y's, don't they? X comma y, x comma y, right? Now with the slope, we'd arbitrarily assign them numbers 1 and 2. Did it matter which one we assign 1 and 2?
No.
No. Think it matters which one we assign 1 and 2 here?
No.
No. Okay, which one do you want to be 1? A or B?
A.
A. So we're going to call this one point 1. We're going to call this one point 2. So that means that this x right here is x 1. And this y is y 1. Okay, it's point 1. Right? This x right here is x 2. This y right here is y 2. Does that make sense?
Why can't the top one be the 2?
It can. It's arbitrary. You can pick.
Oh, depending on the way you do it, like down and then.
Yeah, you can pick. If you wanted to call the B number 1 and the A number 2, that's fine. It's all how you want to write them. Right? But the only rule is if I call B number 2, then the x is 2 and so is the y. Okay, we can't have x1, y2. That doesn't work. It's got to be x is 2 and y. Right? All right, any other questions? Okay, so let's take those x1s, y1s, let's put them in this equation. Let's make this change. Instead of being a delta, let's make it something we know how to do. Right? Now you guys said the delta meant, what was it again? Change, but it means what operation? Subtraction. So if I'm doing delta y, that means I'm subtracting what 2 values?
2 and B.
What about A and B? The x's or the y values?
X is
Y.
The y, so I'm going to do y
1.
2 minus
Y1.
y1. Is it still squared?
Yes, sir.
Yeah. Plus
X2 minus X1 squared.
and that is our distance squared, right? Right? Now, if I want to solve this for d, means I want to get the d by itself, I need to do something radical. Okay? Does anyone know what I need to do? You know the next radical step?
Multiply.
Nope. Square root, right? And some of you might have got my joke. Hopefully that's what you're laughing about. Is that this thing right here is called a radical. That's why I said I need to do something radical. My goodness, that Mr. Branch, he's a smart, funny guy.
No, it's not.
He's as funny as he is handsome, right?
No.
Thank you. That means since I'm not very funny, I must be very handsome. Thank you, Jordan. All right. So this equation that I just put in this blue box, that is the most important equation so far this hour. Okay? But that's the main point. If you don't understand the stuff with the deltas in it, that's okay. If you understand what's in the blue box, that's wonderful. Okay? You need to know what's in the blue box, what that means. Okay? Now, where I got the y2 and y1, where I got the x2 and x1, Kevin, that's from our change in y and our change in x. Okay? Does this make sense, guys?
Yes, sir.
Okay.
Yes, sir.
Now, do you guys want to figure out how far these are apart?
Yeah.
Okay. So, let's figure out what's our change in y. How long is this green line?
A long line.
It's a long line. Very vague in general. Thank you. How long is that green line?
10.
10 units, right? I start here and I count. 1, 2, 3, 4. I keep going and it equals 10. Positive or negative?
Negative.
It's positive.
Negative 10.
Okay. If I started at A and went to B, it'd be negative, right?
Yeah.
If I started at B and went to A, it'd be
Positive.
positive. But because we're squaring this change, does it matter?
No.
No. Okay. What if I go from the x? What's my change in x?
4.
4.
Negatory.
So, basically, I'm going to be doing Pythagorean Theorem to find d, by putting in 10 for A and 4 for B and 7 for C. Does that make sense? Okay. But we're not always going to draw a picture like this, are we?
No.
No. Okay. And our picture might always be as nice as this one. Right? So let's do this without the picture. So we'll just keep the 10 and 4 there, but we'll come back to it in a second. If I wasn't drawing the picture, that means that I know what these x and y's are, right?
Yeah.
Okay. So what are the x and y here for A?
2 and 5.
Nope.
3 and 2.
Here's 0, 0, right? 1, 2, 3, positive or negative? Negative. And I go up 1, 2, 3, 4, 5, 6. Okay. Does that make sense?
Why would you start at 0, 0?
You always start at 0, 0 to figure out what the point is. Okay. How far I went from 0, 0 is how we plot the point, right? Okay. So here's 0, 0. How far did I go? I went over 1, down
0.
-4.
4. So this is 1, -4. Okay. Does that make sense, guys?
Yes.
Yeah?
The greatest.
Thank you, Kevin. See what paying attention does? Now you start out paying attention really well, Kevin, but lately, like the last minute and a half, you've been kind of distracted. Let's get back to that paying attention guy. I think you do better. Okay. All right. So we're going to figure out how to find that distance without drawing the picture. Right? So that means I'm just using this equation. Correct?
Yes.
Okay, what's x1?
-3.
-3. Perfect. If x1 is -3, what's y1?
6.
6. How do you figure that out, Ariane? You just pick. Okay?
C.
We picked this to be 1.
Uh-huh.
Okay, that's why -3 is x1. Okay. We could just as easily just pick b to be number 1. Okay? Alright, x2 is what? 1. Y2 is -4. So now I take these x1s and y1s and x2s and y2s and I plug them in here where it tells me to. Right? So distance equals the square root of -4 minus 6 squared plus
6.
1 minus -3 squared. And that'll give me my distance. Right?
Yeah.
Does anyone know what -4 minus 6 is?
No.
-10.
-10.
Wow, that was a struggle.
Okay? 1 minus -3?
-4.
Positive 4.
Positive.
I think I've seen 10 and 4 before, didn't I?
Yeah.
Yeah, the 10's over here, the 4's right there. Coincidence or not?
Wow.
It's not a coincidence.
It is.
But that's negative.
Okay.
I mean, that's not.
Right, but we're squaring it, so does it matter? No. Okay?
Oh,
Because when I do -10 squared, right?
Yeah.
That means I'm doing -10 times -10, right?
Yeah.
-10 times -10 is?
Positive.
This is a lot.
No, it's not that much.
This is what is one.
Positive 100.
Positive 100, right?
That is one.
Right? So if I do -10 times -10 or +10 times +10, I still get 100, right?
Yeah.
Okay. Try to work out that equation right there.
Wait, what else are you supposed to do?
One. One. She be like one. One. Negative one. One.
Nope.
The greatest.
Use Internet Explorer. Or not Internet Explorer, use
100 plus.
Okay, try one of those then. Okay.
16. I got the answer.
All right.
That's right.
So what's -10 squared? What's -10 squared?
-100.
Not -100.
100.
100. Now, if you guys put this in your calculator like this, -10 squared, it's not going to work. Okay? Because your calculator does the exponent first and then puts the negative sign on it. If you're trying to use your calculator for squaring something, you need to put in parentheses, especially as a negative sign. All right? So if you do that, then you'll get 100 plus 16. 100 plus 16 is 116, right? The square root of 116. So if I want to find the square root of 116, take out your calculator. Hit the second button.
Second.
Okay? Hit x squared. You see there's a radical right here?
Yeah.
Right? Second, x squared. That gives you the radical. Type 116, Crystal, and you'll get your answer.
10 points.
Okay. So 10.77.
11.
Can we call it 10.8?
11.
Okay. I wouldn't round it to 11. That's a little too much rounding. How did I get that? The square root of 116.
What did you press? I didn't hear it. You went too fast.
What?
Oh,
You went too fast.
Okay, 1 second, Kevin. I'm trying to listen to
I
Kaylee.
got D squared.
Or Kylie. Sorry, Kylie.
Wow, you suck with names.
Okay. Kevin, look.
Hold on. Second. Oh. I thought D was squared.
Yeah, you got it?
All right,
Well,
put
we unsquared it by radicalizing the other side. Okay, we took the square root of the other side and get rid of the square. Right
wait,
here.
how did you get 10.8?
The square root of 116. So second, right? X squared is right above log.
Oh.
Okay? And you'll get a radical,
I had a 10.9.
right? And then type 116.
Oh.
Okay? Okay, anyone else?
No. Yeah. Yeah.
Alright. So does the distance formula make sense?
Yeah.
Okay. Now, we will practice the distance formula a little bit more tomorrow, but there's one other formula that I want us to learn today.
Midpoint.
It's called the midpoint formula.
Oh.
Okay? So, when I say midpoints, does anybody know what the midpoint of a line is?
The middle.
The halfway mark.
The exact
Okay.
center.
Perpendicular.
Okay, good. It's the middle of the line, right? So the midpoints, right over here. Okay. The midpoint is the middle of the line, right? Right? It's the point on the line that cuts the line in half. Right? So if I have a line, let's say my line is 20 units long. Where's the midpoint going to be? 10. So the midpoint would be that dot right there. That's 10 units from either side. Does that make sense? Okay. Now you're probably wondering, where does this whole midpoint idea come in? Okay. It doesn't really pertain too much to the sides of a quadrilateral, but more to the diagonals. Quadrilateral. I know, I kind of stuttered it a little bit. All right. But it's more to the diagonals of the quadrilateral. Okay. Now, the whole time we were going through our quadrilateral hierarchy, I kept saying, what about the diagonals? What about the diagonals? And some of us got to the point where we said the diagonals were congruent, right? I think that was this class where someone popped out diagonals are congruent.
Yeah.
All right.
I did.
Now, one other part that's important about the diagonals is the midpoint. Okay? Some quadrilaterals, their diagonals will share the same midpoint, which means the diagonals intersect each other so that they cut each other in half. It's called bisecting. Right? So when the line bisects another one, it means it cuts it in half. In order to figure out if the line cuts in half, we need to know about this midpoint idea. Right? So we got to find that middle point. Okay? So the midpoint is the middle point of the line. So where's the midpoint of this change in y line?
5.
5 from where?
Each side.
Each side. So I start here, I go down 5. 1, 2, 3, 4, 5. Right? Or I start at the bottom, I go up 5. 1, 2, 3, 4, 5. Either way, it's on that line, right? Okay. What about the blue line?
2.
2 from either side, right? 1, 2, 1, 2. That line, right? Now, if I extend these lines, you'll notice that they intersect where?
That one makes 5 and that one 5. 5, 2.
That spot right there. It's not 5, 2. Okay, because our origin is right here. It is -1, 1, right? Because our origin's right here. We left one up 1. And that's the problem with the midpoint theorem. Kevin, please stop. Okay? Is that we think, oh, this line's 5, that line's 2, my midpoint's 5, 2, right? Or my midpoint's 2, 5. But we're finding this midpoint with respect to that origin. Okay? So in order to find the midpoint with respect to that origin, it's like find the average y and the average x. So if I have 2 numbers and I want to find the average of those, what do I do with those 2 numbers?
You add them and divide them.
Add them and then divide by what?
2.
2. We take how many we have and we divide by 2. So if I want to find my average x value, right, or my average y value, that means I take my 2 x's and do what with them?
You add them and then divide them.
Add them and then divide
By 2.
by 2. So we do x1 plus x2 divide by 2.
So then it'd be
Okay.
y1 plus y2.
Exactly. y1 plus y2 divided by 2. So the midpoint of a line, guys, you can think of it as the average x, comma, average y. And Daniel, since I only have 2 points, it's always add the 2 together and divide by what number?
2.
2. Okay? It's always add the 2 together and divide by 2. So I'm trying to find my average x, average y. Does that make sense, guys?
Yes, sir.
Okay? So if I want to use this one, for example, okay, I didn't draw my picture. Instead, I want to use my equation. X1 is still -3. Y, or x2 is still 1,
C.
right? So for this example, I'm going to do -3 plus 1 over 2, comma, y1 is 6, y2 is -4, 6 plus -4 divided by 2. I'm going to use that equation. And you're probably saying, how do I plug it all in at once? You can't. Okay, your calculator doesn't know what to do with the comma. Alright? So you need to do them one at a time. Now I guarantee some of you are going to try this. -3 plus 1 divided 2. And you're going to get -2.5. Is that right?
No, sir.
We need to add first, so you got to put parentheses around the -3 plus 1. Okay? So, -3 plus 1, what is that? -2 over 2, right? 6 plus -4? 2. What's -2 over 2? -1, right? What's 2 over 2? 1. So our approximation with our picture, was it correct?
Yes, sir.
Yeah.
Wow.
Wowzers.
Okay. It might be easier to use the picture, but if you're going to use the picture, that means you need to make a very accurate graph. You need to use grid paper,
That's too much
and you need to
work.
use straight lines.
Too much
Are you going to do that every single time?
Yeah.
You are? Okay. So the equation might be a better route then.
Overachiever.
Okay. Yes, Christine.
Calculators don't understand commas. Why do they?
Because it's helpful for entering things into lists, and for telling your calculator certain commands. Like if you're using 1 variable, 2 variable stats, you need to put a comment as to which list is your x and which list is your y. Okay. Anything else? Okay. Any other questions about midpoint or distance formula? All right. So your 2 takeaway things. What I wrote in the blue boxes. All right. Make sure you have them both written down. All right. All right. Any questions?
No, sir.
None?
No.
Okay. Tomorrow we'll get some practice on these. So hopefully we remember this for tomorrow.